Hi, good turnout. Thank you all for coming. See some tinfoil hats in the room. That's encouraging. I hope you're here to learn about Bash. I hope you've seen Bash before because I'm not going to start super basic. And if you haven't read the man page, hopefully this will be a reasonable substitute or at least inspire you to do so. I also hope that my slides can be a useful reference for future coding. I took things from the man page and put them in table format so that maybe it's more clear what each of these things means. And if you don't think that's true, then, oh well, sorry, you wasted some time. So, my name is James Panacciulli. I am a systems engineer, meaning that I do DevOps stuff, meaning that I use Bash all the time on my stuff, on other people's stuff, on my company's stuff. I work in web hosting, so I'm always touching lots and lots of machines that are then running lots of virtual machines and containers and so forth. With no further ado, there's the slide link, and that'll be up as long as I can keep it up. So, some notes about this. I assume you're familiar with basic command line concepts. You understand you put something in on the terminal and things happen, or they don't because you messed up. I'm going to be talking about Bash, not about all the cool things that you can do on the GNU Linux or other Unicy command lines out there. So I'm not going to be talking about ls and awk. I will assume a GNU Linux machine because that's what you should be doing, and I'm a preacher. And I think that Bash is flexible and fun. So for everybody who's one of those Bash haters, I think that you're wrong, and you're just not. You have to readjust your attitude, I think, because it lets you do a lot of cool things really quick. So the first thing that a lot of people fail to notice is that when you enter some command line, not everything's equal, right? So the command that you are running may be an actual file like bin ls, right? That's just Bash forking out to some other process on the system that's written not in Bash, that's doing its own thing. Perfectly fine, right? But Bash also has built-in commands where it doesn't have to run anything external. It's part of Bash itself. And it has reserved syntactic words called keywords. You can define functions, and your distribution likely already has defined many of them for you. And then an alias is just a simple alias. And so here, this was from Ubuntu I don't know how many years ago. But type -a and then followed by whatever command will tell you exactly what that's doing. It'll even unalias things for you, right? So you see I type -a and I put a few commands, right? So ls is aliased to ls color equals auto, so that gives you the colors when you're looking around your directories. But Bash is smart enough to know that, obviously it doesn't just infinitely recurse on that ls alias, so you can see that it's actually been ls ultimately, right? So you know that ls is a file. Whereas CD is a shell built-in, right? CD is just changing basically an internal shell variable saying what your current working directory is. So an external program can't really do that for you. That needs to be a built-in. While is a shell keyword that sets up a syntactic environment where you can make a loop and do things based on certain conditions. And genpass, this was the genpass function that Ubuntu had defined that was automatically sourced in my shell with the default profile, right? And that's just a quick and dirty way to generate a pseudo-random password with some optional parameters. And we'll get into how all of those cool looking things work. If you want to get help with Bash in your OS, now that you know what types of commands that you're running, it's going to be a little bit easier. Type will tell you what it is. Help will give you help with Bash keywords and built-ins. Apropos will try to help you find the right man page for file command. And man obviously brings up the man page. And then info is primarily for GNU programs, basically kind of like man, more complicated, less people use it. It's good stuff. And then just run these at your own leisure. I think it's worth looking at all of these. Man-a intro should give you an overview of your operating system, so it might be worth looking at. Help tells you how to use help, right? So man, same thing. Just some things a lot of people overlook, but it might actually tell you the one thing that kind of speeds up your daily workflow when you're trying to sort through a problem. Google does not always give you the best answer, So, that being said, these are basically the definitions that the Bash man page uses, and I'll try to stick more or less to them as we go through the talk. That will make it easier for you to look things up later. So a word is a sequence of characters considered to be a single unit. List is one or more commands or pipelines, right? So ls is a list, and ls, pipe, grep, pipe, whatever, right? That's also a list. A name is a special type of word. It only has alphanumeric characters and underscores and cannot begin with a numeric character. And then a parameter is basically a variable, but parameter is a more general term that we'll use here because some parameters are not variable, like special parameters and positional parameters and so forth. So anytime you run a command, you're going to be able to determine whether that command succeeded or failed, unless the person who wrote that command is being uncooperative and don't give you any indication of that. Or if it doesn't matter sometimes, right? So a successful command will return a status of 0, and any other status that's returned is unsuccessful. So the other valid things you can return are 1 through 255. It cannot be negative. And that basically allows you to signal to the end user or to the script that's running it a certain type of error, right, using a different return code. So that way you can have scripts that are sensitive to why your rsync failed, and maybe they can automatically do something to fix this, right? You can react to things in a smart way instead of just saying, well, the whole thing failed, now it's up to the user to figure it out. So if the programs that you're interacting with give good return codes, it's very useful when you're trying to script things and automate around certain types of failure cases, or at least to be able to provide the user some sort of diagnosis to help them as they're trying to track down where their bug's coming from, why they're having problems. So to see that real quick, true just returns true, right? And the $sign in bash obviously introduces an expansion, a parameter expansion. The question mark is a special parameter which encapsulates the return value of the command that was just executed before that. So when we run true, it returns success, and then we echo that return value because it exited immediately before that, and that's 0, which means success. Now, throughout this talk, it's going to be important to look here too. That is in the prompt I have encoded that return value. So for some of these examples, I won't always just be echoing it, and it'll be there. Now, the tricky thing here is you might be thinking that 0 means that the true was successful. In this case, that 0 means that the echo was successful, because the echo was the last command that my prompt saw. Make sense? And you can see that here. False. And then we echo the return value, 1. False failed. Obviously, that's what we want it to do. But my prompt says 0. Not because the false succeeded, but because an echo, it's really hard for an echo to fail. I don't know if I've ever done it. So, anytime you echo something, don't try to check the return value after that because, it's a freebie. So list operators, these are all the ways that we can combine commands into larger lists. Obviously, a list has a list inside, whatever, it doesn't matter. Everything's a list, right? So obviously, a new line is one way to separate things. It's hard to call them a list when you're running them separately. Most people wouldn't, I wouldn't. But if you want to put two things that you're going to run separately in sequence anyway together on one line, you separate them with a semicolon. The first one happens first, the second one happens second. And it's literally the same as pressing enter twice. So if that key gets worn out, this will help. If we want things to happen asynchronously, that is to say simultaneously, or without regard to the ordering of events, we can use a single ampersand. And that will execute the thing that precedes it in the background. Right? So we can put an ampersand after every list and execute them all in the background. In this example, list 0 and list 1. List 0 goes in the background and list 1 runs in the foreground. Whatever happens to list 0, that's going to do whatever it's going to do, and we don't care about it. We can go look at it later. There's job control in bash. You can go investigate it, obviously once list 1 is no longer in the foreground. Double ampersand basically sets up a conditional where list 1 only executes if list 0 was successful. And double pipe is the opposite. It only executes list 1 if list 0 was a complete failure. So we can see some of these. Slightly convoluted example there just to get something that takes slightly longer than an echo, right? And so this ampersand here means that everything before it is going to run in the background, and then the echo hello after it is going to run in the foreground. And then I'm separating it and I'm saying after all of that, I just want to wait. So this just is telling my shell, instead of when the echo exits, to drop me back to my shell and then throw output at me whenever. I want to wait for all of the things that I've asked you to do to complete, including the background task. So we get more output here than we asked for. The first line is bash telling me, hey, I put one job in the background. And then here's its PID, its process ID. The second line is the output from my echo hello, because that's really quick. The third line is the output from head-c5000 dev-urandom. So I'm just pulling the first 5,000 characters off of the pseudo-random device that's available in Linux. And then the fourth line with the 1 again is telling me that my background task, job 1, has completed. Now if I do that without the wait, you see I'm dropped back on my prompt here, and then I just get a bunch of extra text after the prompt that looks weird. It's not actually something I typed. When I press enter, it doesn't do something, except that now that the shell has refreshed, it tells me that that first job exited. So that's why the wait kind of made that nicer, but it's completely unnecessary.
What's wait? Is wait a shell built in?
Yes, we can find out really easily. Wait is a shell built in. So how would I get help on that, right? Help, wait. And then it'll tell you what you need to know about it. And if you need more, then I guess probably just fire up the bash man page and try searching for wait and see all the unrelated uses of the word wait in that man page. So then, going back to true, if we want to talk about tautologies for a second. And same thing for false, right? So these things work very predictably. Get them both on the same screen there. So this is basically how you can take lists, put them together. You can make one dependent conditionally upon the other, or throw them in the background if you want to run a bunch of things at once, or you don't care when they finish, or you don't need them to be on the taking up your terminal input, and so forth. So if you want to do a slightly more complex branching, you're going to use an if statement. These mimic English pretty closely, and I think almost everybody in this room has probably seen one before, so I won't spend too much time. But if list 0 is successful, then execute list 1. If list 0 is successful, then execute list 1. Else, as in otherwise, execute list 2. Right? So in the first box, if list 0 is unsuccessful, that ran. So if list 0 was something that said like, rm-rf root, you already nuked your whole computer at that point. Whether it was successful or not probably doesn't matter, but if it was successful, hopefully there's still enough left in RAM to give you that list 1 and do something. The second one, right, if list 0, so then if that fails, then you're not going to get list 1 to run, and you're going to get list 2 instead. But in the first case, nothing happens if it was failure, right? And so on and so forth with the nested ones. It's pretty straightforward. But for good measure, I'm just going to run any command there. There's tests and stuff we'll see, but it can be any command because everything ultimately has an exit status. Hopefully they were being cooperative and it's meaningful. So I'm just going to look at Etsy OS release and see if I'm actually on Gentoo, which I'm very happy to say this year I am. It had been Arch Linux on the other laptop that I had for a while, and, well, if you like Arch over Gentoo, then we disagree. So tests are very useful, especially with conditional things like if, but you can also just use those as a list itself. So when you run a test, it returns a value, so you can put double ampersand or double pipe after it to branch directly. There's 2 ways to do it. Both actually are in POSIX. Sometimes people talk about the single bracket being the POSIX way, but both are in POSIX. The difference, the reason that people I think use the single bracket for portability sometimes is because there's also the file version of it, which is the weirdest, command I think on the system, just to have it be a bracket. But so if you're running in POSIX shell, but for some reason don't have access to the test command, I don't know how that happens. But anyway, they do have the actual files that can do the same thing for you to run that as a system process. So that's the difference. That's the only reason you would want to use that probably is if you ever for some reason needed that. I would say in general use the double bracket because you can do a lot more interesting things in there. And so the double bracket is a keyword. And that means that Bash is able to parse your string differently and set up a different syntactic environment. So Bash is able to do more things here, right? So word splitting is not performed during any parameter expansion there. Word splitting means Bash will by default split things on white space. So unless you quote word 1 and word 2, that's going to be 5 words. Or 1 word if quoted, right? The right-hand side of a string comparison, when you're in here, and we'll see the different tests soon, is treated as a pattern when it's not quoted and a string when quoted. And we'll see that soon. And you can also do regular expressions. We don't really go over them here, but regular expressions are fantastic. Bash supports them and pulls out things in groups and everything, all the neat things that you'd expect to be able to do with regular expressions. No, you do not need to fire up Perl or awk or sed to do a lot of those things, unless you have to process lots of lines of text and you want the efficiency of those programs, then by all means. But you don't need to fire up external processes willy-nilly just to do one little thing and pull out a line from a string. And then short-circuiting logical operators, much like the ones that operate on lists, are available inside here, so you can combine tests within one bracketed expression. Next line, yeah. So here are those conditional expressions, some of the common ones. If you do help test, you'll see all of them. And then that might confuse you sometimes, so then look on the internet or just play around with them. So we can look to see if a file exists, if it's a regular file, if it's a directory, if the file descriptor is open and refers to a terminal. So that's a way to determine whether you're talking to a person or a script, right? You can say, is this file newer than that one? Is it a hard link to the other one? Is this string empty? Is this string not empty? Are these strings the same or are they not the same? Does it match a pattern? Does it match a regex? Now notice the crucial difference there is that the right side is quoted when we're matching it literally as a pattern. When you don't quote that right side, when we're matching it literally not as a pattern. When you don't quote that right side, it becomes a pattern. And that's the same as file globbing. That's not a regex unless you use the tilde version. So, here we're going to see if the string much content has any content. How do we know that it did? Because my prompt snitched on it. It told us it was successful, right? We can say, is the string while empty? It's not, right? My prompt told us 1. 1's failure. We got something back that was not 0, right? So we could branch on that. That could have been a variable in there instead of a string. That's it's kind of obvious to us, right? If you know what -z means. But this way we can branch on things. We can use variables there and determine if the user actually gave us the input that they promised. So we can run a few of them in succession. I want to know about Etsy, right? Like, does it exist? Is it a file? Is it a directory? So that all runs, and we only see exists in directory. So the one that said and echo regular file, well, I guess -f Etsy must have failed, right? Because it's not a regular file, it's a directory. And here, -t0, if you remember, -t was to tell us if it was basically if it's connected to a terminal. 0 is standard in, right? So 0 is our file descriptor. You could use any file descriptor there. In Bash, you can rearrange file descriptors in all sorts of wacky ways, so that could be important at some point. And if we want to show that I'm not a person, we just replace 0, right? So we're still looking at standard in, but now standard in is not coming from my keyboard anymore. It's coming from a file. So that's false. The script is no longer being fed input from from potentially a live human being, right? I could fake that too, but so when you're writing a script, then you need to know, like, do I turn on the interactive? Do I give them the menu, or do I just make this default if they don't tell me? This is how you kind of branch on that. So we're going to make some files, wait, and then we're going to see if file 0 is newer than file 1, and it's not, right? Because I wrote file 0 first. I waited 3 seconds, and then I wrote file 1. So of course it's not, right? But this way we can do simple tests like that. And we can check if those files are hard linked. Why would they be, right? So first we got 1, it failed. This one failed here, right? So they're not hard linked, but then I made them hard linked. We can see that here. and then it succeeded. We can throw this as our test case for the if conditional. So does ABC equal ABC? Yep. On the other hand, does ABC equal C? Nope. Straightforward. All right. So, pattern matching. All the beautiful stuff that can happen on the right-hand side when you don't quote it. You've seen this probably, ls star dot text, whatever, you know. It's the same thing that it uses for path name expansion. You can use this in pattern matching, which occurs with the case keyword that we'll see soon, or the double bracket, or parameter expansion, and we'll get to that. So star matches any string including null. Question mark does not match null. It has to match any single character. And then within single brackets is a character class, or double brackets with the colon. There are some named classes that kind of make it easier. Instead of going A-Z to go A through Z, you can just say lower, right, or alpha for everything including uppercase, and so forth. The names are pretty self-explanatory. And if you want to negate a character class, that is to say, I want everything that is not A through F, right? Just put a caret in the beginning of that. So here, we don't quote the right-hand side. Does ABC equals star C? Is ABC a string that ends in C, basically, is what this is saying? Or that has any number of things followed by a C, more technically. So yeah, it is. LinuxFest Northwest 2017, does that match A through Z followed by anything followed by not a digit? It does not. Does it match A through Z followed by anything followed by a digit? It does. And we can put stars on the outside. It doesn't change anything because the pattern matching is not exhaustive. So this doesn't need to be like match from the first character to the last character. And it's not regex either, so there's not a way to say this many of this without just repeating yourself, right? It's simple pattern matching, it's globbing. You can throw those stars on there if it makes it more readable, but it doesn't actually change what it's looking for here. But if we change the input, we can see that we can still do the pattern matching. Seems like a superfluous example. And then that one will fail because there's no A through Z. However, if we negate the match, we can do some interesting things, right? We can say, does this not match something that doesn't have a digit? No, right? Because it does have a digit. But this is the way that you would say, I want a string that has no digits with a basic pattern match without using regex, right? You need to do basically a double negative to prove the existence, to prove the non-existence, right, of digits in that string with pattern matching. And that one is just digits. So, pretty straightforward. Same thing from the shell, but from using files, you probably don't get as tricky with file globbing. But when you're looking at strings real quick, this definitely helps speed up the development process. So, case is a great way to use them. Case word in pattern 0, pattern 1, and so forth. So we're going to use word will be basically like the left-hand side that we were just looking at, and then pattern 0 will be the right-hand side, the pattern, and so forth with pattern 1. So this is a way to take one string and compare it against successive patterns and run some code once you find one that matches. Right? So if word matches pattern 0, we're going to run list 0 and then exit. If word matches pattern 1 or pattern 2, we're going to run list 1 and exit. And if nothing else happened, then nothing else happened. So case 1, that's the string O-N-E, right? Is it O followed by something followed by E? Is it O followed by any number of things? Or is it just any number of things? It's O followed by E. O followed by something followed by E. Right? So it's not O because this is that would be a literal O. You need to tell it that there's something more, right? So then it falls down and it checks the next one. That one matches because the question mark can be substituted with the N, and so it prints what I told it to print, and it exits. It doesn't check farther. It would match O star, but it doesn't get far enough. There is a way to tell it to cascade, but we won't go into that here. So here are some parameters. We have the positional parameters, the special parameters, and then user-defined variables. Positional parameters, when you run a program, you give it arguments, they get filled from left to right positionally. And that's using word splitting. So if you quote your first argument that has a few words, then that all gets thrown into $1. Otherwise, it's $1, $2, $3, and so forth. You have to put them in the braces, the curly braces, once you get above 9, to let it know that this is still the variable name and not expand variable 1 and then put a 0 after it. Special parameters, we won't go into all of them, we'll kind of see them around, but they can tell you things about the number of positional parameters, or give you all of them with word boundaries protected. And we saw $question already as the error code, and so forth. And then to define a variable, name. Remember, name is a special type of word, does not begin with a number, and it's only alphanumeric, and underscores. And then equals, and then whatever you're assigning to that name. Usually a string, but we could also use this to make arrays, we'll see later. Crucially, no spaces around that equal sign. It's not like other languages where that equal can be 5 miles away. Bash will only look at it as an assignment if its name equals string immediately. If you have spaces there, it's just going to think these are random arguments or a command name that happens to have an equal sign in it. And you'll just see weird things happen. So when we expand things, there's the simple way where you just say $variable, and it just prints whatever's in the variable. And then there's the interesting way where we can expand it in interesting ways to get different results and do tests or substitutions or excise parts of the string. Lots of nice things. So this is one of those tables I was telling you about. So param is the name of our variable, and the curly braces can always be used in an expansion. But if we use some certain special keywords here that are in orange in the middle of that expansion, they tell bash to do certain things, right? So if param was unset, that's the first column. This is what you get when you echo this thing. If param was set to an empty string is the second column, and if param was set to an actual string like GNU, that's the third column. So this way you can kind of get an idea when you look at these, once you've used them a little bit. This is one of those tables you can look at to say, which one of these do I need for this case that I'm trying to test for this thing, right? So the minus will return a default value. So let's say you're taking user input into this variable and they don't provide any, or you're looking for a file and it wasn't there and it ended up empty, whatever, right? So this way you can say, what directory do you want me to save this in? They don't put anything. You can just do dash and then put, $home or something, right? Use their home directory as a default because you assume that's somewhere that they can write to, or temp directory or something. If you want to actually assign that back to param instead of just using it in the expansion, that dash becomes an equals. Otherwise, when you're expanding this with a default, it's only affecting the way that variable is interpolated at the time that it runs. It's not reassigning that variable without that equals. Plus will give you an alternate value. So if I do have a value in this variable, I'm going to print this other thing instead. And then a question mark will error if there's nothing there. So you can put a custom error string in here if you want to basically say, just use this variable in this command, and if that variable was for some reason unset, abort immediately, don't actually run the command, drop an error, a custom one if you want. But that way you don't have to set up an extra explicit check before running that command. You can just put it in the line and do it the quick and dirty way. And so it's all the same beneath there, except that we treat empty as unset. So that affects, obviously, the alternate value in the empty case. And excuse me. Let's look at some examples of these. So we're going to set some positional parameters here. Set dash dash, everything that comes after dash dash is as if we had run a program with positional parameters, but it's just in my shell still. So this will just kind of show us some of the special parameters that we can pull out of a string, out of the environment when a command is executed with positional parameters. So $1 is 1, $2 is 2, $3 is 3, 4 because they were quoted, so they weren't split, and $4 is 5. So we have 4 parameters. $5 is empty because there was none. So $bang tells us how many arguments there were, 4. $star just gives them all to us as a string, and $ampersand gives them all to us, but split by words. So here I'm printing it per line. So 1, 2, 3, 4 together again. Right? So these are some of their special parameters interacting with the positional parameters.
Is that an array?
Which?
$at.
Yes. Yes, $at is effectively an array, and it maintains the word splitting, whereas $star just kind of puts it all as one big string if it's not important. So here we can run something and we can save that error and then look at it later, right? And return that. We can still run the rest of our function or do whatever else needs to happen and retain that error. But that's one of those things you got to remember to do if you want to use that error code later, because it won't stick around after you run another command. So when we're expanding these things, let's have a param that is set to an actual string, and it's going to return the actual string, right? I gave a default value for expansion, but we didn't use it, right, because it actually did have content. On the other hand, if we unset it and then echo it, we're going to get the default value. Does that make sense? So this is where you can easily use user defaults. Is one thing that I really miss in a lot of other languages. You have to do kind of janky stuff, and it's really nice to just build it right into the variable expansion. We can use a nifty custom error string, right? So here we see the 1 in my prompt. The command failed. It's an echo, which I said never fails, right? Why did it fail? Because I told bash, when you're expanding this parameter to feed into the echo command, if there's nothing there, let's just fail out with this error, right? So this could be that RM, if they didn't put slash, then we're just not going to do anything and assume they don't want to destroy everything. And we can look for a path and make sure that they have one, right? So this is where you can use the alternate value and be sensitive to things. And one of the ways that people use this a lot is they'll just use plus and then some string that they're looking for, and then compare that to something to see if they got the thing that they're looking for. People do kind of weird things like that, but basically with the plus you use an alternate, so it's a way you can check to make sure that something's set without actually using it, or still use the thing that you need and kind of put that into the command to make sure that the other thing that they're going to need later is still set or was set at all. And so we can do other neat things taking substrings, so you don't have to print the entire variable, right? You can just use the part that's useful to you in that moment. And this kind of allows you to put things together too. You can kind of make your own little data structures. You can say, well, these strings are each going to have a colon in the middle, and the first thing's going to be the file path, and the second thing's going to be the command or something, right? You can do whatever you want there, and just kind of use this as a quick way to take either side of that character that doesn't appear in there again or something, right? So you can use this to kind of build machinery like that. Extraction's pretty straightforward. You're just going to take an offset. So if our param is mandrake, offset of 3, length of 2, we get drake. Offset of 3, no length, we get drake. So it goes in 3 and then takes the rest of the word. Length of 2, we only get the dr. If we're going to remove from the left edge, and I like to think of these left edge, right edge, pound comes at the beginning of the comment, percent comes at the end of the number. And so they just come in from that edge, right? So param and then pound pattern. So our pattern is star A, same pattern as globbing, same pattern as the test we just saw. We're going to take everything up to the first A, right? So it's just going to be n drake. If we double up the pound sign, it makes it greedy. So it's going to match from the left side of the word all the way across as far as it can find until it finds the last A from the left. And it's just going to leave us with KE. So percent does the same thing from the other side. Obviously, I got to put the asterisk on the other side of the A since we're coming in from the right. So we're going to match up to the first A coming from the right, and that gives us mander. And if we get greedy, we go all the way across and just are left with an M. There is no way to say, I want to take 2 in. You would just have to iterate or something. It's either the first or all the way across. But you can just keep reassigning and taking off the parts that you want if you want to do it that way, instead of, piping the value into sed and doing a regex there or something. Or you can use a regex in the shell. But this is, the quick way to do some things that you just need to expand it once. You don't need to worry about saving everything, right? So with bash version, that's something that's just set in your shell anyway. We can just take the first character off of that to know that we're using bash 4 and not bash 3. If you're on OS X for some reason, you'll notice that it's bash 3 because they don't care about you. So if we want to take that path and greedily remove everything from the left-hand side up to the last colon, that'll leave me with the least significant part of my path. The part that has the binaries that I care so little about that if something's named the same as them beforehand in my path, it gets executed instead. So the thing that I care least about is core Perl, I guess. So with these, obviously, it's very powerful, and if I wanted to do this and make it not greedy, I just lop off the first thing. I lop off the thing that I care the most about, right? Or I can come in from the other way. If I turn the star around and then turn that into a %, right? And now I've lopped off the thing that I don't care about because what was I going to run from there anyway, honestly? We can also substitute things when we expand the value. So our param is Ubuntu. Pattern can be U question mark, so U followed by something, and our string is just X. In this case, we're going to replace the pattern with the string. So a single slash replaces once, and a double slash gets greedy. And we can also ground it to the left or right edge, so we can do a replacement. And there's not a greedy version of this, but you can do a replacement that's anchored to one edge or the other by putting the pound or the % afterwards. And the same mnemonics kind of apply with numbers and comments. So to see these, we're going to take my path again, and I'm going to use -e to let Echo know that it can go ahead and give me new lines when it sees a \n. And so now I can actually read the path, right? Because when it's a long colon separated value, your eyes aren't very good at parsing that. So we're going to replace those colons with new lines, and suddenly it's very clear what's in my path. So just quick and dirty way again with variables that are already set. We don't need to change the variable. We don't need to pass it to a bunch of programs. We don't need a loop. We can just quickly display something to the user that we're storing in a different way and just manipulate it upon expansion. So it's very powerful. We can do indirection. We can list things, and we can give lengths of things, right? So the box has some givens for these examples to get those results, basically. So indirect expansion, you won't use that often, probably, but it's basically kind of like a pointer, right? So if name 0, the value of name 0 is name 1, and name 1 is also a variable whose value is hello, when I expand bang name 0, it gives me hello. It gives me the variable, the value of the variable that name 0 points to. So you can actually set up pointers this way, or you could put them all in an array and get really complicated and confuse everybody who has to maintain your script. When you have a bunch of variables set, one nice thing is putting a prefix on them. Right, you can say, my script is called Jim, right? So I can say, I'm just going to say _Jim begins all of my variable names, right? And so then I can go bang _Jim star, and that'll list every variable that begins with that. And then I can loop over those variables or do whatever I want. And the same thing basically works in an array. It'll tell you, well, we'll see that later. Don't worry about that. It'll tell you all the indexes, basically, but we'll get to those examples more later. And then the same thing, we can see the length. If it's a string, it'll give you the number of characters. If you're looking at a variable that's an array, it'll give you the number of elements. So yeah, these are wrapping around a little with this resolution, but hopefully it's not too discongruent there. We're going to set a parameter, and we're going to give the value of path. Hint, there's going to be some indirection. And then we're going to print things with a couple new lines after each value that I'm printing. So let's just see what we get. Right, so $param is path, and an indirect expansion of $param gives us the value of $path expanded. And then if we want to actually go ahead and operate on the value that we're expanding from the indirect expansion, we can still do that and take the most important thing from my path by excising all of the text from the right-hand side in greedily until we find a colon. Does that make sense? It's kind of a convoluted example. You might not use something like that very much, but some of these things can be combined. You can't get too creative. Bash will tell you, obviously, that it failed when it fails. There's a lot of ways that you can't combine these things, but that's one of the ways that you can. I don't know that I would recommend that you do. These are all the variables in my system right now. I didn't make any of them. They were just there when Bash loaded. That begin with capital BASH, right? So Bash has lots of information about itself. You can refer to these variables in your script to learn things about your user's environment and so forth. And my path is 103 characters long. Any questions about parameter expansion in general? Good. All right, so arrays. More complex data structure than a string, obviously. Same kind of assignment. Don't put any spaces around the equals. But we're going to use parens, and it'll do word splitting inside, right? So quoting applies the same way. So that's going to be a 4-element array, that first line. And you can add to it with a plus equals, which you can also do with strings, by the way. And that will just append to a string. And with an array, it will append to the latest, well, it'll create an index, a new index at the latest index, basically. And you can also use the plus equals notation to modify an element that's in there, right? So with array equals 0, 1, 2, 3, and more, 0 is going to be our 0 element, right? We start counting at 0 in Unix. So here I'm actually going to add 1, and I'm going to reassign 0 to be capital ZERO instead of lowercase ZERO. And you can do those both at the same time. So it's a nice way to modify things. We can recreate it as a different version of itself, right? So these are similar to the things that we saw with string expansions, right? But we're modifying the elements of the array as they are expanded. We're not reassigning them unless we were explicitly reassigning them as I am here. So the part inside the parentheses here, we could also just print that instead of reassigning it to itself. But if we took an input and we just, we're the type of people who hate spaces in our file systems and we're creating files, we can do something like this to take that array of files that we're going to create and just replace all of the spaces and all of those names with underscores. Personally, I have nothing against spaces and file names. It's 2017. We can also just take elements, so this isn't going to apply to the values of each of those elements, right? This is going to take elements 2 through 4 out of the array. It's not going to take characters 2 through 4 out of each element of the array, right? So we're operating on the elements of the array here, not the characters and the strings that may be the elements of the array. And to retrieve a certain element, pretty common array syntax there. Just put the index inside the brackets, inside the expansion. And here you definitely need the braces on these expansions for any of the special modifiers that we're putting in there. And the bang will show the indices. So to show some of these in action, right? So we're going to set that array, and then we're going to print each one by line. Right? And notice I'm using we could expand the whole array. You can do it like that too, right? But that loses all your splitting. It loses the fact that 3 and more is one element and not 3. And there I was just printing it by line. So we can add something to it, right? And now when we print it, we see that extra element added. It's on its own line because it's one element still because it was quoted. We can go ahead and print it with underscores instead of spaces. Or we can just take a slice of it. Or we can go ahead and list the indices. So maybe we want to loop over these individually for some reason, right? So we can say, we'll get the for loops, but for index in bang array at, right, we can get all the indexes and loop over them manually. You can do a lot of math in the shell, but you cannot do floating point. Although there is a guy who did write functions in bash to emulate floating point. If you know the math of doing floating point, you can do that, right? But that's more than bash really should be doing in general, and it doesn't handle it natively. So generally, if you need to do floating point math in the shell, you're going to use awk or BC or Perl or some other contraption to do that for you. But any kind of normal arithmetic, including modulus and fun things like that, which help a lot in programming, all available in bash. You can do increment and decrement. If you put it after the name of the variable that you're incrementing or decrement, it does it after evaluation, before it does it before. And so forth. And if you put a $sign in front of the double parens that enclose the arithmetic expansion, it will expand the value as text. Otherwise, without the $sign, it runs it like a test, right? So it just says, is this successful or not? It returns 0 if the comparison equality or inequality is true, or if the calculated number is not 0. So if you're just looking at a number, or something that just evaluates to a number inside double parens, then it's going to fail if that number ends up being 0. So here we can print one, right? So we can print the result of 3 plus 11, 14. We did good. We can just do a test to see if 3 is greater than or equal to 5. My prompt tells us that it is not because we got a 1 in the return value there. And we can see if a 0 fails or not, and it does, right? And so this could be anything that evaluates to 0. 35 minus 35, it's going to fail. 35 minus 34, and we're okay, right? So if you just want to branch on whether or not something has a meaningful number, and if 0 is meaningless in this context, then that's a simple way to do it. Or you can do the comparisons and equalities and so forth. And then we can also just go ahead and echo a variable. Inside the expansion, you don't need to put the $sign. You can on that variable. So here I'm using a variable I. I hadn't set it before, so I didn't have to initialize it. And bash automatically assumed that it was 0 if I didn't say otherwise. And it printed 0 even though I have the incrementer. That's because the incrementer came after. Now if I run it again, it's 1. But what is the value actually? The value is already 2 because the incrementer ran after. If I put that incrementer before it, then we're going to see the next value already. And it's going to be the same when we look at it later. Brace expansion gives us arbitrary word generation. Pretty fun to play with. We can generate strings, we can generate sequences, and we can generate sequences with specified increments if you're running bash 4 or greater. Escape left curly brace is very fun to play with when you're tabbing. If you are tab completing some files and you want to see the nested brace expansion version of that tab completion, just press those keys and it looks weird if you have a lot of files. And you can show all of those bindings, everything that you can do, or everything that you haven't actually set a binding to that you could do if you were intrepid with bind-P. And I recommend doing so. But let's get back to brace expansion. They can be nested and combined, and the prefix and suffix are optional. So with commas, we're just doing generation of strings, and those are applied to each successively. And with the double dots inside, we're setting up a sequence. So when you see, backtech, SEQ, yada yada, people running sequences that way, you don't really need to do all that and call an external program to make a sequence in bash. It's all built in. So here we're going to generate some arbitrary words. We have a few prefixes and suffixes, and results of these expansions also become prefixes and suffixes, right? And so here we can get all of these words out of something much less meaningful looking and more compact. And I generated that by making files from the dictionary and using the escape thing, because it would be it's annoying to make these manually when they're all nested, and there's not much reason to do that, really. But it's fun. Right, and we can do the same thing. We can generate a range of percentages using expansions as prefixes and suffixes of themselves. Or, if you're running bash 4 or greater, you can go ahead and build that increment in natively. And here the only suffix we have is the % sign. Right, so here we're listing the same percentages, but we don't have to do the machinery ourselves. Now it's built in if you have bash 4. You can also use letters and ranges. There's much less reason to, but there's a good one. And one of the most useful things, I don't have a lot of useful examples in here, and somebody called me out once and said, especially with brace expansion, you're telling us how to make words like GNU or Amy or something. So here's where I actually use this all the time, right? You just want to make a quick backup of something or rename something. Instead of typing the whole thing out twice, you can just throw a little brace expansion on the end, right? And then I made a test file, and then I copied it to testfile.back. Or I could have moved it, renamed it, whatever, right? So that's one of the more useful things that you'll get out of this talk.
Is that making an array or a string?
Sorry?
Is that making a new string?
Yes.
String or array?
Yes, so actually, we can look at that right. Well, no, we can't do that. Yeah, so basically what happens when it expands that brace expansion, it makes test file space testfile.back, right? And that's just because the left-hand side of the comma in that expansion was empty. So the first expansion, it just gives us the same prefix that we put before it with nothing changing. And then in the second expansion, it adds the dot back. We can run commands this way. I told you to run man to learn how to man, and there it is. You don't even need to type it twice. Completely useless. Compound commands. All right. We can iterate. We can do conditionals, and we can do command groups. So iteration, we're going to do in loops. We're going to loop over lists of commands. You remember them from earlier. Those are going to be inside do and done. That tells the loop when to start and when to not be started anymore. And while, until, for, and select are the loops that we're going to talk about in bash. Conditionals, same thing, execute lists if they meet certain conditions, and we already saw that with if and case. But those are compound commands, which is important for the definition of function later. And command groups are grouped lists of commands sharing any external redirections whose return value is that of the list. So when you group these commands and the whole thing exits back to your primary shell, the return value is that of basically the last thing in the list, whatever the list returned as a whole. But if you do redirections around that whole list structure, they apply to everything inside of it. So it's a nice way to group a whole bunch of commands together and take all of the standard error and throw it in one file instead of having to repeat yourself 12 times. So, while and until loops, we're going to, while list 0 is true, do list 1. Right? So execute list 0. If it returns success, we execute list 1, and then we circle around again. Unless list 1 broke the loop, we're going to execute list 0 again and see if that still returns success. So once it returns fail, we're done, and we move on to the next thing after the loop. Until does the exact opposite thing. Until list 0 returns success, we do list 1. So list 0 fails, we say, great, I'm going to run list 1. List 0 fails, great, I'm going to run list 1. List 0 succeeds, oh, our work here is done. And while read is an incredibly handy construct for parsing lines of text in bash. Instead of piping them to an external program or something, you can just take each line in, read sets a variable. We'll see some of that later. Quick example of a for loop with read. We'll see some of that now, I guess. While read variable 1, variable 2, we're just going to echo them in the reverse order, variable 2, variable 1. So I press enter, nothing happens. Why? Because I didn't tell it where to read from, so it's assuming that I meant to type something in here, so I'm going to say 1, 2, it's going to say 2, 1. That's pretty good. What if I say 1, 2, 3? It's going to say 2, 3, 1. Why? Because with read, the last variable name that you give it grabs everything on the rest of the line if it gets more than you were expecting. So if you only want the first two things and you don't want, if the user might just keep typing or something, go ahead and throw an extra junk variable in the end to catch anything else. Otherwise, you're going to get weird things. Even if you don't care about it, it doesn't matter. Go away later, right? Until, it does the opposite. But let's say we have a count variable, 0, and we're going to increment that count. And until it's greater than 3, we're going to echo it. Right? So 1, 2, 3, and then it was 4, and we no longer echoed it. Right? So if we look at it now, it's 4. Crucially, because we incremented it before expansion. And we can go ahead and pipe things into while read, right? So here we're saying, let's get a list of files from ls. Why not? And then we're going to do some fancy business on them, get some stuff from stat, get some stuff from MD5 sum. All right, and here I'm going to, it basically gives me the list that I asked for. I'm printing each of these manually, so you can kind of very quickly put together your own, instead of using ls and trying to dig through that man page and maybe it doesn't have what you need. You only need certain columns, certain information. You have programs on your system that'll get it. Now you can put them all together easily based on what's going on in a directory, or you could pipe anything into this, right? With for loops and select loops, it's a little bit different. So one thing I'd like to put out, while and until loops typically iterate based on an external resource, and for and select loops iterate based on command line arguments. What I mean is, when we just saw the while loop, one of the things we were doing is while read, right? So any number of lines, I could sit here typing for days, weeks, months, years, and it'll keep reading it, right? It doesn't know when the end will be until I press Control-D and kill it. With a for select loop, it's different because it's for name in words. Words is right there in the command line. They have to expand at the time that for loop is run. So that's not just going to sit there listening indefinitely to something, because the command line can only be so long, actually. I mean, there's going to be a limit on your system. It's pretty high. Depends on how your stuff's compiled and what things are set. But at a certain point, your command line can't get any larger, and Bash just says no. So here, there's once it starts running, you already have the whole list of everything that it's going to run on, is the difference. So for name in words, so name is the name of a variable that gets assigned inside the loop based on each word that gets parsed out of words for each iteration. And then we're going to run list. And list may or may not refer to the actual variable, but it's there inside the loop if we want it, our name. And just repeat until all words have been exhausted. Then we have the C-style for loop with an initialization, a condition, and an afterthought. So it's in an arithmetic expansion for a reason, because these are math things, right? So we start with expression 0 that says maybe count equals 0 or something. Expression 1 says, less than 4. And expression 2 is an afterthought. It happens after each iteration. So that might be, count plus plus, right? And then we do the list as long as those conditions are all met each time. Select is the black sheep of the family here. It's not a loop in a normal sense. It sets up a little menu system for your user. So if you have a list of things and you want them to be able to press a button, that's a really easy way to do it without writing the machinery yourself. So for file and star, we're going to echo the stat, echo the MD5 sum commands that I put, and it's the same thing that we got before. So we can see those side by side more or less. The whole echo command doesn't fit on the screen, but these do the same thing, right? One of them is using a while read loop, and the other one is using for file and star, right? So the while read loop, in theory, ls-1 could be a command that just throws files at it indefinitely. It may not just be looking at a directory and exiting. Maybe it's waiting on, it's tailing a file, and every time a new thing's written there, it writes the file name here, and we do something else, right? The for loop, obviously, is just going to operate on whatever we put there. It could be a star, it could be something else that expands the file names or whatever. But these can do the same things. You just might use them in different situations, right? So here we have for I in 1, 2, 3, 4. We're going to echo them all pretty like. Obviously, a useless example. Fill in your own useful code later. I don't know what you guys do. Here's the C-style for loop, right? So we have our initialization, our condition in the middle, and our afterthought, which increments it there. And then we're just going to echo it each time it goes through. So once I was no longer less than 5, that is to say it became 5 itself, we exited the loop and stopped echoing whatever I was. Similar thing here, just to show you what that actually is doing. If we want to write the C-style for loop as a while loop, there it is. Does the same thing. So to put those side by side, we see we have the same initialization here as here, and then while colon just means while forever, I don't care, I'm going to break out of it some other way. And then we just do, because we have this here, right? We have our condition there built in, so that's why we don't put it in the while loop, and we can just break and then echo it. So the same thing can be written different ways, right? And then select. So here's our 1, 2, 3, 4 again, but we're going to call it choice instead because the user or the customer is who's important. So now I have a menu. What do I want? Well, I think I want 2. Great, 2 is 2. 43. Well, that's nothing. 3. That's something, right? So this is a loop because it'll keep doing that unless I tell it to break out in my code, which I don't. So this is the rest of the talk. We're just going to do this. Just kidding. Control-C throws a sig in, and then we see the return code of that thing failing because I killed it. So we can also go ahead and iterate over things that might be more useful. Even though I keep promising to not be useful, this might be slightly useful to somebody, right? So now I have a list of all the files in this directory, and I can say I want to know some statistics about file number 11. Great. I have access to all of these things except birth, because I guess my file system, I don't know. Has anybody ever seen birth? I don't know. How do you get birth? I don't know. Who cares? The file's going to, everybody, all this can be changed anyway. You can't trust a file system. But yeah, so you can run any kind of arbitrary commands this way based off of a dynamically generated list of things, right? And provide a menu to a user, which you might want to check for with the test-t that we remember from before, because if a script is sitting there looking at this menu, well, I don't know what you expect to happen. So command groups, they treat a group as a single unit for redirection or branching. So we have the subshell, which is enclosed in parentheses, and the group command, which is enclosed in the curly braces, and obligatorily a space on the side inside of those braces and a semicolon at the end of your command list. Why those kind of arbitrary seeming restrictions? Because otherwise Bash wouldn't know that you didn't mean to do brace expansion. And we don't want Bash to just arbitrarily generate words when we want it to actually run commands and do interesting things for us. So make sure you put those spaces and semicolon there when you're doing the group command. So the difference between the subshell and the group command is that the subshell runs in its own distinct child shell, and the group command runs right here, right now in your current shell. Why is that important? Usually because of variables and stuff. So in a subshell, all variables are effectively locally scoped. Anything that happens in there dies in there. Other than writing files and doing permanent things. When you're doing a group command, you can set all the variables you want, and they're still there when that group command exits, because that's your current shell that's still active, still in memory. So we're going to unset x, make sure that x isn't anything already. Inside a subshell, we're going to make x, assign x to a value, and we're going to echo it, and then outside of the subshell, we're going to echo x. So inside the subshell, we get x is hello, and outside the subshell, x is still nothing. It's still unset from up here. If, however, we do that as a group command instead of in a subshell, x is still set outside of the group command. And I guess the nice thing about this, other than scoping, right, like I said, the redirections apply to it and stuff. So if I do something like this, it applies to all the commands in there. Not that x equals hello puts output, But if we had a whole bunch of things that put output and we wanted to group them all together and say, I don't care about any of this output, that's the quick way to do it, right? Just pipe it all to dev null, basically, and forget about it. And you only have to write it once. And obviously you can do much more complex things than that. But that's the premise. So if you're running bash 4 or greater, and not bogged down by the Steve Jobs OS legacy of the world, you can use associative arrays. In Perl, they're called hashes. In Python, for some reason, they're called dictionaries, even though dictionaries cannot have multiple values. But this is the same thing basically in bash. So you have to use declare-big A array to make it an associative array. Once it is, you can do these fun things with it. So instead of assigning by index number, although you could put a number there arbitrarily, you can put any arbitrary thing in there as your key, and then it equals your value, right? So let's make an inventory system here. My item is cheese, my price is $6.75, and the type of thing is fresh curds, right? So we first have the array of cheese and the price, and then later the employee who goes and does inventory comes along and plus equals onto that array to add an element type equals fresh curds, right? If we want to copy that array, we can use declare-n. That'll make an exact copy of that array into array 2. And we can list the array keys with our indirect expansion, the bang, and we can list array values by not including that. So let's see some of these. So declare-a assoc is my associative array, right? We have a port and a service. And then we're going to print some stuff. Right, so key is service, value is secure HTTP. Next key is port, next value is 443. Right, and that's just coming from my printf here. I did a little fancy business where I put in a new line and a couple spaces to indent, right? So if you want to take an array and print it in a user-friendly format or store data that way, right, this is kind of the way to get those keys and values. And all I'm doing here is looping over for key in the expansion of keys with that bang there, right? And then I can reference key later inside the loop, and then I can use that key as the index on my associative array to bring out the value at that particular item. Unfortunately, there's not like a way to refer to items of an array. You would kind of need to break it out and go through it manually if you want to do it this way. Otherwise, you can take items basically directly, but it's not. You can't treat them as such in Bash. You need to do it manually. But it is all there, and you can use those kinds of data structures, which is very handy sometimes. So we can do something called file sizes is the name of our array. That's declared. It's done. Bash knows it's associative now, right? And then we can say for file and star, if it is a regular file, -f test, right? So that's to say it's not a directory, it's not a socket, it's not some weird stuff. Then we're going to go ahead and add that item to our array with the size in bytes of the file as the value, and the file name as the key. And then below that, I have a for loop that goes ahead and prints that out for us so that we can see that it did something. So I print it bytes, and then I gave a width so that everything lined up in a nice column, right? So you can do quick things like this, get you where you need to go. And one thing that is good to know, declare-p, oops, the name of that was file sizes, and you can tab complete variable names in Bash. Right, so declare-p will print that all out all as one, and you can see my key equals my value and so forth. And this is a consumable form, basically. This is a command right here, so you could just take that and put it somewhere, which we'll see later. Redirection, you're probably vaguely familiar with this at least. We have the pipe at the bottom there, which is one of the things that really makes people see the power of command line environments is being able to use the output of one program as the input to another, right? It lets you automate work in a very seamless way. But there's other things we can do, right? We can take the output of a list of commands and put it in a file, or we can append it to a file, or we can read in from a file as input to commands. If not specified, file descriptor 1, standard out is assumed when redirecting our output. So when you use a pipe, it's going to take standard out and throw it over the pipe unless you say otherwise. Yes?
Yeah, I've got a question on that. In the last couple of years, I've noticed a lot of people like to emit fancy color codes
Yes.
in their output. And that really breaks the whole pipeline.
Well, it depends. It depends on what's on the other side of the pipeline, right? Some things are going to barf on it. Some things are going to discard them. Some things are going to keep them. Like in general, if I pipe something to less, it might just be my distro's less settings, but it usually just loses the color formatting, and I don't see all the weird codes.
Yeah, but if you want to do some additional processing,
Right. Yeah.
you got to strip out the code.
Right. Yeah. And in that case, it might be worth just throwing it into set or something to strip those things out. But
Yeah.
yeah.
I think with less, what you're seeing is often commands will, or sometimes I think ls does this, commands will check
Right.
the output is a terminal command.
Yeah. Some commands will be smart about what they're putting out to, but I know like on some distros I've gotten the stuff in less and some not, so it must be a less setting. But anyway, programs can be smarter or less smart about it. You need to know what you're throwing over the pipe to be able to know how to deal with it, basically. So for a couple quick examples of redirection, we're going to take a few random numbers, slices of them so that they're the same size, and then we're just going to print them and sort them. Right? So our printf is outputting directly into the sort program instead of to my screen, and then sort is putting stuff on my screen. Right? Here we're going to just do a whole bunch of pipes. We're going to man bash, and we're going to pipe the whole bash man page into tr, translate spaces into new lines to get the words, and right. So we're going to basically just make a histogram here. Long story short, the appears 4170 times in the bash man page. This is the next most frequent, and so forth. Right. So the most frequent word in there that's not just an article or something is a shell. Not surprising. And here, this is something that a lot of people might get tripped up on. Echo B, echo A, sort, what do we expect? Not BA. Why did we get it? Oops. We got it because these aren't grouped, right? So we're echoing B, and then we're done. And then we're echoing A into sort. So here's where we need one of those group commands. It could be a subshell or not, right? As long as those are grouped, now that output is going together over the pipe. And we can actually get them sorted the way that we were thinking it would happen, right? So just because something's on the same line doesn't mean it's together. And if we're going to put something in a file, right, we can just use echo or something else that produces text and throw it into awesome.txt. And then we can use cat, and we can go the other way with the less than sign to read from awesome.txt. Now, of course, we can also just cat awesome.txt, but that's just because cat's flexible. Right, it can take standard input when we're redirecting, or it can take a file name and go ahead and read it for us. Either way, right? But some commands only work one way or the other. But this way we can get input and output from and to things in a reasonable manner. So with that, we can get a little more advanced and do command substitutions off of our subshells or process substitutions. So these are always going to be subshells. These you can't do in the same environment. So the command substitution replaces inline. So that's a way to build a command line out of a program's result. Like whatever that program does, it spits out a bunch of things, and that becomes the rest of your command line. It substitutes that whole expansion with the output of that command inside. Whereas process substitution is a way to treat the output of a command as a file, either for input or output to your command, whatever you're running. So instead of replacing on the line, it just replaces it with a file descriptor, a path to a file descriptor, basically. So it acts like a file as far as the program is concerned. So if you have one of those really annoying programs that says, no, I need a literal file to work on, usually you can get around it by just doing this if you wanted to use a pipe or something that they didn't want to let you do.
You get word splitting?
Sorry?
Do you get word splitting on command substitution?
It depends on the environment. If it's directly in an assignment, then you don't need to worry about the quoting, but otherwise you do. If you quote the whole substitution, then you will get proper word splitting. So here we have an example. We're going to run a command date plus %f, so we want to get a date in a nice format. That'll give us our file name based on the date, and then we're going to echo things into it, which are also expansions. So here we just have a few expansions going on. And we slept a second, right? And so now we can cat file name, and we have the 2 lines from the 2 dates. And yeah, our file name is actually file 2017-0506 if we expand it. And that's Control-Alt-E if you want to expand a value directly on the command line. If we want to see some more examples of this, Here we have the substitution inline on the command line. And then this is a special case where you can take a file name and it's kind of like a cat, basically. Instead of saying cat file name inside the expansion, you can just use the arrow. It looks a little confusing, but saves a couple keystrokes.
Why didn't you have to escape those quotes?
Sorry?
Why didn't you have to escape the quotes around file name?
Oh, because they're inside the expansion. So that's already a protected zone. Bash knows about what's going on in there, so you don't need to get crazy double, triple, quadruple escaping everything inside. You can just go full transparent there, which is very nice. Just like here, right? So here we can show that we're actually running these all in subshells. Right, so in the very middle, I'm saying, give me the process tree for everything from the current shell that I'm in, but that's after I'm already a few levels deep, right? So it gives me the whole tree with my PS all the way at the bottom here on the inside. Now, the other way to do it is with backticks, and there we don't have protection, and we do have to escape, and it's really awful. And I really, really highly advise against ever using backticks. There's no reason. Backticks are the same as the dollar parens, except that they make things much dirtier and harder to read, and it's not, you know, they're the same on both ends instead of being matched, so it's just visually it's harder to parse, and if you want to nest them, it just gets bad. So we can go ahead and take this as a file in the path, and here what we see is that our echo path, when it was expanded, became a file descriptor, dev fd63, right? So if we didn't want to see that in the output, we could go ahead and tell WC to take that as on its standard input instead of presenting it as a file. So Bash will just go ahead and take from that file descriptor and then put it through the thing anyway, right? So you can do anything that you need. You can be flexible with respect to what you want the program that you're ultimately calling to run. And so here we have an example where we're going into instead of out of the process substitutions. Tack is like cat, but in reverse, right? So we're doing tack, and then in another one we're sleeping, and then we're doing cat. So that's why we get it backwards, 3, 4, 2, 1, and then 1, 2, 3, 4. And that's using T to fork out the same text to both of those programs. So if T is a good way to basically, it's like a splitter, right? And we can do that all inside a variable, and now it's saved as a variable. Same difference. And we didn't need to quote it because that's a special case in assignment. We didn't need to put quotes around this. Bash knows to keep that all together properly for us. And we can go ahead and fill up an array like this, hi, hello there, so forth. And then when we look at the array with declare-p, we see that everything is in its proper place. It will not work this way. Array not found. Why? Because on the right-hand side of a pipe is a subshell. So this while loop is inside a protected subshell where everything's locally scoped, and so this whole array that we're building here gets thrown out completely by the time we need to use it down here. So what you need to do is instead take the input in the other way, and then we can have it in our shell fine, right? So here, crucially, the difference is that while is not on the other side of a pipe anymore, it's in our current shell. So when we're setting this array here, it actually is meaningful after we're done. So the difference there, basically, instead of having the pipe, which you can't see because of the size, so yeah. We won't put those side by side. It's all right. You get the point. This is how we do diffs, right? I'm using an array of examples, actually, to bring these up so quick instead of doing all the typing. And so that's how I was getting those things, basically. But we only have a few minutes left, so let's try to move on. Functions. We're getting to the good stuff here, right? So function name, compound command, right? So any of those compound commands we saw before can be functions. Usually people just use the curly braces to designate functions, but you can also just do function and go right into a for loop. And redirections will apply permanently. So let's see a few of these real quick and then see some of these as actions. So words is going to be a function that echoes words. So words 1, 2, 3, 4, right? Straightforward. So now we can abstract our code and call it things. We can reverse characters. I won't go through all these examples in full detail so that we get through. but we can rev cars hello, and we get ole, right? We can take that function rev cars that we just made and put it in another that says rev words, and now I can say rev words hello, hi there, right? And so each of those words is getting passed to the function, and so we can nest our functions and build complex, wonderful things, big programs that do lots of things. If we want a quick and dirty way to get some memory statistics about programs using pmap-d, which gives a good measure of how much something's actually using on the system. This is not a way that I would recommend measuring things in real life because it's kind of slow doing it through bash this way. But you can basically make your own top really, really quick and dirty in bash doing things like this. We can pull random word out of cracklib small, and by random I mean we're pulling random letters, or not even letters because you get all sorts of garbage, random stuff from the pseudo-random device until we happen to find a 4-letter word that's in our cracklib small dictionary. Completely useless, right? So this is going to run that, and it's going to tell us I tried 196 times until I got 4 characters from the pseudo-random device that happened to be a word in the dictionary. To me that seems like pretty good. I don't know. Run it again. 332 tries this time. Right? We can prepend an identifier. I like to use this when I go to remote things, right? So word, right? So I'm prepending an identifier word. What does that mean? Well, hello. Okay, word is hello, right? We'll see why that's useful maybe when we look at session portability. So now that we've declared all these cool things, we have our arrays, we have our functions, we have all the stuff that we want to do, but I'm still on my laptop and I need to do it on 100 servers over there. What am I going to do, right? Well, I'm going to wrap it all up in a declare statement with -p for my parameters, -f for my functions, and then I can just run those directly on the other side. Very transparent. Anybody who's tried to do a for loop with SSH with commands running on the other side has probably gone through escape hell, where they're trying to put backslashes in front of everything until something works, and maybe they get the wrong thing to work, and just because it gave output doesn't mean it was the right one, right? Well, this can help clear that up because you're testing your functions locally. You're looking at them in your own environment, and you can run them remotely and get the same results back. So let's show some examples of this. So I have some Docker containers running, so I'm going to do for host in this convoluted Docker command that I need to run to actually get IP addresses from the damn thing. And then I'm going to declare -f random word. So I'm going to get that random word from each of these Docker containers, and then I'm going to do an MD5 sum for the hell of it. And I'm going to prepend identifier to tell me what host these things are coming from. Eventually. There we go. So the container ending with .5 for the IP address. It took 230 tries to get maze. The next one actually 13. It's amazing to get gaf, and then 27 to get gain. This is why pseudo-random devices are not the best for doing security, I think, right? And then 397 for the last container to get run, right? So these all just execute within sequence, as I told them to, on these remote hosts, even if they might be local, because, you know, conferences and Wi-Fi, I don't tend to want to do live things on the internet. And we can get more complicated with this, right? So we can go ahead and do things. And here I have these stupid escapes in here again because I'm trying to get more complex with the functions that I wrote, and I didn't think to break them out yet. So this is doing a similar thing, but it's going to take that word, and instead of giving us the count of times it took to get to a word from the pseudo-random device, it's going to take the word and find other instances that have that word in it in the dictionary. So gaps, I guess, appears in no other words. Swim does appear in swim, swimmer, swimmers, swimming, and so forth, right? So here we're doing something slightly more complex, but it's starting to look like garbage. So up here we can go ahead and declare a function that makes this a little bit more readable down here. It would be more readable if the screen were, you know. But down here then we're going to just be able to do get words remote. So we just have to declare -f each of those functions to throw them over the wall onto the other server, and then I'm just effectively running one function. And then outside of SSH, on my side, I'm putting the host name before it so I know which container said what. Sorry, the pseudo-random is maybe not the best presentation trick. All right, well, that one's taking a while, so moving on, we can take that and we can say, since I don't want to wait forever because the first one's being slow, every time I run this, I'm going to run it asynchronously with the ampersand, because there was an implicit semicolon effectively with the new line before. So now I'm going to background my weird function useless thing on the other side. I'm going to wait to make sure I collect all the output. So here I have bash telling me it launched 4 jobs in the background. First one spits back, and then we get bash telling me job 1 is done. And then we get all of them back eventually. They happen to be in order this time returning, but they don't need to be, right? It's going to be asynchronous. It just depends which one exits first. Right, so here you can have a quick and dirty way to go out to all 100 machines at the same time and have it do the same thing to all of them. And since I'm prepending the host name to the output of each of them, if something weird happens on one of them, I can see it on my side in the log and know which one said what. And to take that, well, that was the last example. So to sum it up, I think session portability is where this stuff gets really interesting, because you can play with everything on your own machine, or remotely for that matter. You can define everything in a file and source that and have all your functions ready, or parameters that you need to send somewhere. And it effectively lets you run things without having to copy scripts around and remember to have the right versions of things here and there. So if you're a DevOps guy like me, this stuff is invaluable. A lot of people in my work like to run Fabric and stuff, but I really don't understand the point of trying to write bash in a Python script and then worrying about the version of Python on the other side, if it's able to run your bash for you or not. So this to me is much more straightforward. And at the end of my slides here, I have a few good links. At the very bottom, to toot my own horn, is basically a slightly suited up version of what I just showed you for running things on remote servers that handles a few more cases. And if anybody uses that and has any future requests or comments, I'd be very happy to hear them. And then I think I have 3 minutes if anybody has any questions. Yes, sir.
Do you have any tips on debugging bash scripts?
Yeah, well, there's set-x, and that gives you all the confusing output to make your head spin, but is sometimes exactly what you need. So set-x will basically tell you at each step what is happening. You know, when you're assigning a variable, what are you assigning it to, and so forth. So that's the first place I would start. Some people write scripts with set-e, which means on any error, the whole script fails. I usually like to handle my errors personally, but yeah, otherwise it can be just kind of tricky. Yeah. Yes?
What tool are you using to pass through all your examples?
I just wrote some custom functions and stuff. I'll put it up on the get.jpnc.info eventually when I clean them up a little bit for public consumption. Thank you.
Thanks.
That was a very good presentation.
Thank you.
I worked for a company that was a Unix house. That's all it was. Pretty gooey.
It's all you need.
Yeah, right.
Thanks. Thank you. Very good. Thanks.
You did some examples with regex matching in Bash earlier. Is there a way to make it do extended regex, or do you have to type that in like egrep or set or something?
No, it only does, well, I forget which flavor exactly, but yeah, it only does the one flavoring. I think, unless there's it might be a, unless it's in here.